All right, we're in section 5.5 where we're going to divide fractions. So in 5.4, we looked at multiplying fractions, and in this section, we're looking at dividing fractions. One of the nice things about this is it's essentially we're going to be doing the exact same thing. So, but to kind of give you um, a little bit of perspective, we have a couple of statements that are written here. First off, it says, what can you multiply by to get a product of 2? And then it also says, what can you divide 4 by to get a quotient of 2? So when you multiply 4 by something to get a result of 2, I guess the one that would be a little bit easier to solve for is the divide one. So 4 divided by something is going to give us 2. Well, we know that 4 divided by 2 is going to be a result of 2. And looking at what we're going to try to do today is 4 times it by 1/2 will give us a result of 2. So if we were to kind of take this here, you say 4, make it into a fraction, times it by 1/2 over here. We know that 4 and 2 can be reduced. This is going to be 1. This is going to be 2. 2 times 1 is 2 over 1, which equals 2. Makes sense. All right, so now we want to be able to figure out the relationship between 1/2 and 2. The relationship between 1/2 and 2 is they are reciprocals of each other. Reciprocals is basically you take a fraction and you flip it, all right? So even though 2 isn't necessarily a fraction at this time, but you can write it as 2 over 1. And if you were to flip it, the 2 would go in the denominator and the 1 would go in the numerator, and that's how we come up with the 1/2. So if we look at another example, we know that 6 times it by 2 is going to equal 12. So that means that 6 divided by 1/2, which is the reciprocal, should equal 12. Because let's think about this. When we talk about dividing we talk about dividing fractions, what we're going to do is this will be changed to a multiplication problem, and we are going to flip the second value. So now I got 6 over 1 turns it into multiplication, and when I flip it, it turns into 2 over 1, and it gives us a result of 12. So what this next page is telling us here, this is the one rule about dividing fractions is you can't do it. You can't do it, so that means you must make it into a multiplication problem. So all we are doing here is that once we have a division problem, we immediately make it into a multiplication problem and we multiply it by the reciprocals. Okay, so that's the one thing that we need to take from dividing fractions. So if we look here, look at this one right here, we got 1/2 divided by 4/7. So immediately what we're going to do is we're going to change it into a multiplication problem. And all we did was division turned to multiplication. And the second fraction got flipped, not the first, just the second. And then the result is 7 over 8. All right, looking at this one here, 3/4 stayed the same. Multiplication, flip the fraction. So I think it was like keep it, change it, flip it. I think that was what you guys are customary to hearing. And then result is the product of the numerator and the product of the denominator. Go over here. Again, make it into a fraction of with 5. Flip the fraction on the second one. and you get a result of 25 over fifths, 25 halves, or 12 and 1/2, or 25.5, however you wanted to write it out. Again, same thing, make it into a improper fraction, turn it into multiplication, and then you can get your results from there. Okay. So let's try some other examples. So we have 2/15 divided by -8/25. So first thing you got to do is make it into multiplication problem. So you keep that first one, change it to multiplication, and then flip the fraction. Excuse me. And I also like to keep my negative in the numerator. And then we can do exactly the same things we did in 5.4. We can reduce where we need to. 2 and 8, both of them are divisible by 2. This becomes 1. This becomes 4. 15 and -25. 5 they're divisible by, so this is -5. And this is 3. So this turns out to be -5 on the top and +12 on the bottom. If we look at the next example, we have 4/7 divided by 5. So you keep the 4/7, turn to multiplication. Remember that this is 5 over 1, so when I flip it, it turns to 1/5. Looking at this, it doesn't seem to be anything that I can cancel out, so I just multiply it across. 4 times 1 is 4. 7 times 5 is 35. All right, and there's my answer there. Okay, so now before I do any multiplication for these two examples below, we have to make them into improper fractions. So 6 times 3 is 18, add 1, that's 19/3, divided by, so I got 27. 27 plus 8 gives us 35/9. Okay, so we have it as a mixed number. Or I'm sorry, not a mixed number, we have it in an improper fraction. So now keep the 19/3, change it to multiplication, and then I get 9 over 35. So I see that 9 and 3 can be reduced. This becomes 1, this becomes 3. 19 times 3 is 57. 1 times 35, 35. And that is in lowest terms, but if we want to make it into a mixed number, we got 1/35, because 57 goes into 35 once, and what's left over would be 22. Okay. Finally, looking at the last example, uh, put it into an improper fraction. 3 times 4 is 12. 13, so it's negative 13 over 4, divided by, so that's 32. 32 plus 5 is what, negative 37. Remember, put back on the negative value. This is going to be negative 13 over 4, times it by negative 8 over 37. Remember, it doesn't matter where you put the negative in the numerator and denominator, but I just like to keep it in the numerator. This can turn into -2. This can turn into, oh, I'm sorry, that's wrong. Let me go back. Let's write this again. Negative 32 over 4, times it by negative 8 over 37. This can be divisible by 4, so this turns into -2. This turns into 1. My apologies. And then negative 13 times it by -2 is positive 26. And this turns into 37. And I believe, yes, this is in lowest terms. Okay. And that is being able to divide fractions. Hope this helps. Till next time.